Morning to all of you. Today we have discussed about the topic is namely ultrasonic waves. Before going to the session, let me introduce about myself. I am Dr. Ravichandran, Assistant Professor, Erode Secondary Engineering College, Perundurai, Erode. Now we are going to the session. So what does it mean the ultrasonic waves? How do you explain the ultrasound? So in general, the ultrasound is an imaging test that uses sound waves to create the picture and also known as the sonogram of organs, tissues and other structure inside the body. But unlike the X-rays, ultrasounds don't use any radiations. We already know about that. So who ultrasound introduced it? So beside the ultrasound was of brainchild of engineer Tom Brown and abstraction Lan Donald. They were first people who crafted the prototype system that created it contrasted and an instrument served the purpose of detecting the flaws in the industrial ships. However, in the 1970s, it became widely used. So, what is the ultrasound? So, you can see that the animation picture, the ultrasound is the sound waves with the frequencies higher than the upper audible limit of human hearing. So, the ultrasound is no different from normal audible sound and its physical properties, except that human cannot hear that. These limits varies from person to person and approximately 20 to 20,000 kilohertz in healthy young adults. So ultrasound device operate with frequencies from 20 kilohertz up to several gigahertz. And ultrasound is used to many different fields like ultrasonic devices are used to detect the objects and measure distances. Ultrasound imaging or sonography is often used to medicine in the non-destructive testing of products and structures. And ultrasound used to detect the invisible flaws industrially. Ultrasound is used to for cleaning, mixing and oxygenating the chemical process. And also the animals such as birds and porpoises use the ultrasound for locating the prey and obstacles. Okay, so what is meant by the sound? So what is meant by the sound in general? So what is meant by the, so before that the ultrasound combined the Latin roots, the ultra mean beyond and sonic means sound, the having frequency about 20,000 hertz and have application for imaging detection and navigation. The broad sector of society of regularly apply the ultrasonics technology or medical community industry and the military. So you can see that the picture. So first you should understand the sound. So what does it mean the sound? Something is around on you, or otherwise sound is a mechanical wave that results from the back and the forth vibration of particles of the medium through which the sound waves is moving. So when we put on the switch, obviously glow on the light. So whatever to be there in the starting point, the end point. So something is moved from one point to another point. Likewise, the motion of the particles is parallel to the direction of the energy transfer. This is what the characteristics of sound waves in the air is the longitudinal waves. So you can see that the animation picture, the sound waves is the longitudinal waves and the other something is waves like ultrasonics and light waves and so on, transverse waves. So in this wave, longitudinal wave motion, the form of energy is emitting the vibrating body and propagation is all directions. So you can see that the picture, the sound waves with the frequency too low for human ear to the hear the called infrasound and above, I mean the over 20,000 kilohertz is the infrasound. In our human body is, human being is audible range 20 to 20,000 kilohertz. Okay, likewise the infrasound is the below 20 hertz. So the example of animals such as whales, elephants and hippopotamus are use the infrasound to communicate over distance. So likewise the infrasound and ultrasound, the animals such as dogs, bats and the insects can hear the ultrasound. So here depending upon the frequency, it has been classified the three groups. Likewise the infrasound, audible sound and ultrasound. So the frequency range is 0 to 20 is infrasound, audible range is 20 to 20,000 hertz and the ultrasound is 20,000 hertz to 5 megahertz. So the example of ultrasound infrasound is earthquake and audible sound is speech and music, and ultrasounds is birds and quartz crystal. Okay, so here, so what are the properties of ultrasounds? Though it has been the high energy contents, waves get reflected and refracted, absorbed, and here the transmitted over the large distance with no appreciable loss of energy. So we need to understand when we applying in the when we send the some data from the starting point to terminating point without any loss, it's moving from one point to another point. That is the reflection of ultrasonic waves. So it has been the serves as a diffraction grating called as acoustic grating, and it produces the intense heating effect. So we need to the protection of ultrasound waves, the magnet restriction generator or oscillator, and the second one is piezoelectric generator or oscillator. So it has been classified the two protection methods like a magnet restriction and piezoelectric generator. So you can see that the picture, animation picture like the magnet restriction effect. So now we are going to discuss the magnet restriction generator. When a ferromantic rod like iron or nickel are placed in the alternating magnetic field parallel or perpendicular to its length, the rod experiences a small change in the length. And you can see that the picture, the north-south pole, which means the magnetic field. So if you consider the one magnetic rod, so when we are applying in the magnetic field during the time, it has been something is moving, which is nothing but magnet restriction effect. So next, the production of ultrasound waves, likewise the magnet restriction generator already we have discussed, and this one is the principle of magnet restriction method. And here already we have discussed, if you consider the ferromagnetic rod, say when we apply in the magnetic field, you can see that the north-south pole, so it's moving from something is changes like increase something is something means it changes the length or decrease the length. So change in length, increase or decrease, it produces the depends upon the three categories and three process: the strength of magnetic field, and the second is the nature of the ferromantic material, and does not depend on the direction of the field. So you can see the circuit diagram that we have discussed in the NPN transistor base emitter collector, and already we have set in the ferromagnetic rod the upper side, the clamp, it has been fixed in the clamp. When we are applying the magnetic field, it produces the ultrasonic waves, and the XY is the rod of ferromantic material like iron or nickel. The rod is clamped in the middle. The alternating magnetic field is generated by the electronic oscillator. The coil L1 is the attached to the variable capacitor C1, and it has forms the resonance circuit because the collector tuned the oscillator. The frequency of oscillator is controlled by the variable capacitor. The coil L2 wound on the left hand portion, the rod is connected to the base circuit, so that we can call it as the L2 act as the feedback loop. So here it is the working principle. When high tension battery is switched on, the collector circuit oscillates the frequency F is equal to 1 by 2 pi root of L1C. So this is the L1 is the inductance coil, C is the capacitance, and F is the frequency. So this is when we switch on the battery, the collector circuits oscillate with the frequency. The alternating current flowing through the coil L1 produces an alternating magnetic field along the length of the rod. The result is that rod starts vibrating to the magnetic restrictive effect. So as you know that the frequency of vibration of rod is given by n equal to 1 by 2 del root of y divided by rho. The L is the length of the rod, and y is the Young's modulus of the rod materials, and rho is the density of the rod materials. So now the rod is vibrates longitudinally the maximum amplitude, and that generates ultrasonic waves of high frequency from its the end. So what is the advantages and disadvantages of magnet restriction method? The design of oscillator is very simple and its protection cost is very low. That is the important advantages of magnet restriction method. At low ultrasonic frequencies, the large power output can be produced without any risk of damage of oscillator circuit. So very important disadvantages of magnet restriction method is it has very low upper frequency limit and cannot generate the ultrasonic frequency above 3000 kilohertz. That is the important disadvantages. And in addition to that, the frequency of oscillates depends on the temperature. There will be losses energy to the air series and eddy current. So next we are going to discuss the piezoelectric method. So already we know that The protection method is two types. The one is piezoelectric method, other one is magnetostriction method. And just before that, we have discussed the magnetostriction method, but now we are going to discuss the piezoelectric method and principle inverse piezoelectric effect. So here itself, the two type of definition we have discussed. The first one is a piezoelectric effect, and the next one is inverse piezoelectric effect. So what is the piezoelectric effect? If mechanical pressure is applied to one pair of opposite pieces of certain crystal like quartz, equal and opposite electrical charges appear across its other faces. This is called as piezoelectric effect. The converse of piezoelectric effect is also true. That if an electric field is applied to one pair of faces, the corresponding changes in the dimension and the other pair of faces of crystals are produced. This is known as inverse piezoelectric method or electrostriction method. Okay, so thus before I have informed to you the two we have discussed the two type of piezoelectric method. The one is piezoelectric effect, and addition to that, inverse piezoelectric effect or electrostriction effect. So as per we have discussed in the previous session, I mean the magnetostriction method and NPN transistor. Already we know that the NPN transistor and high tension battery, and L1 L2 is the inductance coil, C1 is the capacitance, and here itself in addition to the secondary coil L3 and the crystal. So in this point is it produced the ultrasonic waves. So the quartz crystal is placed between the two metal plates A and B. You can see that the picture, and the plates are connected to the primary L3 of a transformer, which is inductively coupled to the electronic oscillator. Already we have discussed. You can see that the picture, and the electronic oscillator of circuit is based due to the oscillator circuit. The coils L1 and L2 of oscillator circuit are taken from the secondary of transformer T. The collector coil L2 is inductively coupled of base coil. So as we know that the alternative voltage with frequency F is equal to 1 by 2 pi root of L1 C1. The L1 is inductance coil, C1 is the capacitance. And after the tedious process, the frequency of vibration given by N equal to P by root L, 2L, and Y by rho. Y is the Young's modulus, rho is the density of the crystal. So what is the piezoelectric method, the advantages and disadvantages? The ultrasonic frequencies has a high 510 to the 10 power 8 Hz or 500 megahertz can be applied to this arrangement, and the output of this oscillator is very high. It is affected by the temperature and humidity, and disadvantages are the cost of piezoelectric quartz is very high, and cutting and shaping of crystal is very complex. So this one is very important disadvantages, and as before we have mentioned the advantages of 5 into 10 power 8 kilohertz, I mean hertz, and or 500 megahertz can be applied to this arrangement. And also the output of this oscillator is very high, and you can see that there's some animation picture. So it could be observed the non-destructive testing method. Okay, so what is mean by the non-destructive methods? A method of finding defects in the material without causing any damage up to the material. You can see that the picture, and the probe is moving from left hand to right hand side. So the input peak, the transmission pulse, the output pulse is back or echo. If any defect is present, the in between peak is present. You can see that the animation picture. So what is the purpose of non-destructive testing is very important topic. The method of finding defects is a material without causing any damage to the material. So most of the common non-destructive methods are visual inspection method, liquid penetrate method, and magnetic particle inspection method, and ultrasonic flaw detection, and eddy current. You can see that the second one animation picture, the eddy current testing, and X-ray diffraction method, and so on. So here, how is ultrasound used in non-destructive testing? You can see that the animation picture. As before, I'm told you like when we moving from the transducer left hand to right hand side, the ultrasound waves are emitted from the transducer into the object and return to the waves are analyzed. So in case if an defect is present, the sound will be reflected and the signal is received and then the analyzed. So there are two methods of receiving from the ultrasound waveform. The one is transmission mode and other one is reflection mode. So first we are going to discuss through the transmission mode. Okay, you can see that the picture, the T is the transmission, R is the reflection. You can see the first one, there is no defect. You can see that the second picture, in case any defect is present, as per I'm told you, like the sound will be reflected, the signal is received, then analyzed. That is the transmission method. So advantages of transmission method and disadvantage of transmission method. Okay, so what is the advantages? Means less attenuation of sound energy, and addition to the no dead zone on the screen, and orientation of the defect does not matter in the way that it is does on the pulse echo display. So what is the disadvantages? A defect cannot be located, compound surface must be parallel, and vertical defects are not seen and does not provide the depth information. That is the very biggest disadvantages of non-destructive methods. And there must be access on the both sides of component. And you can see that the some animation picture. So what could you observe in the animation picture? The two type of echo pulse echo method. The one is single echo method, other one is multiple echo method. Because now we are going to discuss the pulse echo system, or otherwise reflection mode. You can see that the picture A and B is the input pulse and B is the output pulse. Already we know that the CRO, that is the reflection ultrasound recorder, are analyzed, and CRO is nothing but cathode ray oscillation scope and pulse generator and amplifier at the right hand side. So here itself the pulse echo system through the reflection mode is the transducer is it's act as a both transmitter and receiver. The first picture, left hand side picture, is shows on there is no effect, so that we'll get the input pulse A and output pulse B. So you can see that the second picture, I mean the right hand picture, in case any defect is present, the reflected wave is the C. In this place the defect is present, so that we can clearly observe in the CRO, I mean the cathode ray oscillation scope. So what is the advantages and disadvantages of transmission, I mean the pulse echo method? So it has been the high penetrating power, high sensitivity, and only one surface need to the accessible, and greater accuracy and some capability of estimating the size, orientation, shape and nature, and non-hazardous to operation to to nearby the personnel, capable of portable or highly automated operation. And disadvantages of the manual operation requires very careful attention by the experienced technician, and the extensive technical knowledge is required. And pots, those who are rough, irregular and shaped, very small or thin or not homogeneous, are very difficult to inspect. And surface must be prepared by cleaning and removing the loose scale paint, and couplants are needed to provide the effective transfer of ultrasonics wave and energy between the transducer and pods. And you can see the some animation picture, though this is nothing but modes of display. Okay, now we are to discuss the modes of display. The ultrasonic data can be collected and displayed number of different formats. There are three most formats are known as non-destructive world as Scan, Scan and Cscan presentation. So slightly is difference difference is available, because the Scan is amplitude mode display, because you can see that the picture given only one dimensional information. You can see that the picture, the signal is amplitude and back wall echo and crack top, crack bottom. So we can get the only one dimensional information, and echoes are displayed as vertical spikes as a function of depth. And the height of spike is proportional to the strength of the echo. So we need to the distance at which the defect present, so that D equal to V into T. And similarly the B-scan display, so depending upon the brightness mode display, you can see that the picture, it has been the two-dimensional image. Okay, the penetration depth and voltage. In addition to the transmission can be moved, but compared to the A-scan is transducers cannot be moved, and echoes are displayed as a dots, brighter dots and dark. The brightness and size of the dot depends on the intensity of the strength of the reflected echo display. And the final one is Cscan display. This is three-dimensional information that provides the location, size and shape of the defect. You can see that the picture, the right hand picture, the side view, the test piece is present here. So when we moving in the transducer, if in case any defect is present, so we could observe, we could found the location, size and shape of the defect. So scanned over the test piece, the relative signal amplitude is displayed as a portion. So the applications of ultrasonic waves. So people are using the welding. The ultrasonics welding is an industrial technique whereby the high frequency ultrasonic acoustic vibration are locally applied to workpieces being held together under the pressure to create the solid state weld. And the principle of ultrasonics welding. In the ultrasonics welding, frictional heat produced by the ultrasonic waves and force is used for the joining process. The ultrasonic waves 15 to 60 kilohertz are transferred to the material under the pressure with a sonometer. So welding times are lower than 3 seconds. Within 3 seconds, the welding can processed with or without the application of external heat. So applications of welding machine, the edge neatening of fabrics for joining up the motif and for sealing the edge of ribbon or lace, for making tie, for shaping the parts of garment, making buttonhole. And the next application is the drilling. The ultrasonic drilling is a non-traditional loose abrasive machine process. In this mirror image of shaped tool can be created in hard brittle materials, and so we easily broken materials like the brittle materials. The materials removal is achieved by the direct and indirect hammering of abrasive particles against the workpiece. And the hard materials, stainless steel, glass, ceramics, carbide and quartz and semiconductors are machined by the process and has been efficiently applied to machine glass, ceramics, precision and mineral stones, tungsten, brittle materials. And you can see that the various work sample using the ultrasonic drilling. The first picture are shown in the plastic sample, that is the inner grooves that are machined using ultrasonic drilling. And second one is the plastic sample has complex details on the surface, and third one is the coin with the grooving done by the ultrasonic drilling. So what is the application of drilling process in ultrasonic waves? And a nearly limitless number of future shapes and cavities of varying depths can be machined with the high quality and consistency. So machining, wire drawing, punching or small blanking dies. So what is the advantages? The drilling that requires little power to operate, nearly zero torque is needed to operate the drill. The drill is able to properly function at both extremely low and higher temperature, so does not produce the electric, thermal, chemical abnormal surface, can drill circular or non-circular holes in very hard materials. So what is the disadvantages of a drilling process? The difficult to drill much past an inch to very dense material. Ultrasonic drilling provides the very little tolerance surrounding the bit, henceforth no pathway is created for the cutting fluid, low material removal rate, a high tool via occurs. So next, the other medical applications of ultrasound use the cancer treatment, neurosurgery to clean the teeth and also for dental cutting, used for cataract treatment, and the fatas in the womb can be viewed in the sonogram, and focused ultrasound may be used to break the kidney stones, and the ultrasonics gates and many other different kind of medical applications are ultrasonics are used in. And next we are going to discuss the cavitation. The rarefaction results in sudden drop in the pressure causing growth and collapse by the gas bubbles, and you can see that the first picture, the bubble forms, it gives the bubble grows in the successive cycle. In addition to that, it gives the reaches the unstable size, so the 500 degrees Celsius undergoes the violent collapse. So that what could be observed, the rarefaction results in sudden drop in the pressure causing growth and collapse by gas bubbles. It means collapse, the pressure increases about 1000 of atmosphere and temperature about 10,000 degrees Celsius. And applications of ultrasound waves, it is used to ultrasonic cleaning and ultrasonics cleaning. and to clean the teeth and also dental cutting and cavitations. It is accelerated the chemical reaction to locate the mineral and oil deposits, and it is to the emulsification. So next, the final is the important application point in the ultrasonic waves, the sound navigation and ranging, the pulse echo effect. So in this process, you can see that the picture to find the depth of the sea, direction and the distance of the submarine. You can see that the picture, the submerged submarine, and it gives the input waves, then reflect the waves. In the reflected waves are analyzed using the CRO, and we can get the depth, and some other machines or some other parts are missing. We could find out easily the location and the depth of the sound navigation page. Okay, so the distance traveled by the sound is 2D is VT. Okay, thank you.